Okay, we're going to continue on. So welcome back to Anatomy and Physiology Day 80, Part 2. So we're going to focus on just what's going on with the male reproductive system here. So this is additional information. So this is not really going to be something you're going to be tested on. So if you want to pay attention to it, great. If you want to just focus on the Part 1 material, that's really kind of what I need you to know. So kind of going through here, we'll start off with the testes. So each testes is connected to the trunk of the body via what's called a spermatic cord that houses blood vessels, nerves, and the ductus deferens, sometimes known as the vas deferens. Covering the testes, there's something called the tuna abolinga. It's a capsule that surrounds each testes, and then inside of that, there's the septa, which are extensions of the capsule that extend into the testes and divide it into these lobules and break it up into smaller areas. So here's that tunica abolinga kind of going around the outside, and then here you can see kind of extending in, breaking up the septums, breaking up into those lobules right there. So each little grouping is where we're going to be producing sperm in the seminiferous tubules there. So there's 1 to 4 seminiferous tubules, these tightly coiled structures. They function as sperm-forming factories, and they empty into that rete testes, which if you back up is kind of this mid-region here. But you're producing, if you're male, something on the order of about 1,500 sperm per second. So it's a pretty high rate of production there. Sperm travel from the rete testes to the epididymis. So they go from here into this area out here. And then interstitial cells in the seminiferous tubules produce androgens such as testosterone. We mentioned that before. Okay, so the duct system in males consists of that epididymis, the ductus deferens, and then the urethra. And all this is designed to move sperm from the testes out of the body through that route there. So the epididymis is highly folded, highly convoluted, 20 feet long, 6 meters or so long, located on the outside of the testes there. It's the first part of the male duct system. It serves as a temporary site for immature sperm. And they mature as they journey through the epididymis. As we mentioned before, though, it can take quite a number of days. So from the beginning, spermatogenesis with the back here with the seminiferous tubules, all the way through their time in the epididymis can take on the order of 60-something to 70-something days. And then during ejaculation, sperm are propelled through the ductus deferens, eventually kind of out into the vas deferens here, right? So it runs from the epididymis during the spermatic cord through what's called the inguinal canal and arches over the urinary bladder. There's an area called the ampulla, which is the very end of the ductus deferens, which empties into the ejaculatory duct, and then this passes through the prostate to merge with the urethra. So we won't talk about it today, but one thing that happens with men is they have the potential to develop prostate cancer, in which case they will sometimes go in and they'll remove that prostate and they'll remove that ejaculatory duct that passes through it. Sperm move by peristalsis into the urethra, and then ejaculation is the smooth muscles in the wall of the ductus deferens create these peristaltic ways to squeeze that sperm forward there. The urethra, again, is that extension that goes out from the urinary bladder to the tip of the penis. It carries both sperm and urine in males, and the sperm enter from the ejaculatory duct up here, and up there. And then in the urethra, we have these 3 different regions of the prostatic urethra. Then we have the membranous urethra, and then the spongy urethra going on down. And again, ejaculation causes this internal urethral sphincter to close off because we don't want sperm going backwards into the bladder from the ejaculatory duct there. Yeah, and so we look at some of the accessory glands. There's 3 major ones we want to focus on: the seminal vesicles, which are these ones here, the prostate, which surrounds this one here, and then the bulbourethral glands, which are down there. So the seminal vesicles are located at the base of the bladder. They provide a thick yellowish secretion. It makes up about 60% of seminal fluid by volume. It contains fructose, which is a sugar for the sperm to kind of nurture them as they go through, vitamin C, molecules called prostaglandins, and then other substances that nourish and activate the sperm. The duct of each seminal vesicle joins out a ductus deferens on each side to form the ejaculatory duct. The prostate encircles the upper part of the urethra. It secretes a milky fluid which helps activate the sperm, and then the fluid enters the urethra through several small ducts there. And then the bulbourethral glands are these pea-side glands just inferior to the prostate, and they produce a thick, clear mucus which cleanses the spongy urethra of acidic urine prior to ejaculation. And the mucus serves as a lubricant during sexual intercourse. All right. So seminal fluid itself is this milky white mixture of sperm and accessory gland secretions. So components of these accessory gland secretions include liquid portions, act as a transport medium to dilute and carry the sperm. Sperm are cellular tadpoles is kind of a way to think about it. As we mentioned, fructose provides energy, and then the alkalinity, the high pH, so it's not acidic, it's basic, of seminal fluid helps neutralize the acidic environment of the vagina, and then semen inhibits bacteria. So we want to not carry bacteria with us when we are in the act of sex. That's not polite. And then external genitalia that we look at, we've got the scrotum, which is down here, and the penis, which is down there. Okay, so the scrotum, as I mentioned, is a divided sac of skin. It's outside the abdomen, so there's kind of a right pouch and a left pouch within the entire scrotal sac to keep the testes separated there. And then the reason they're outside the body, the normal cavity there, is that sperm apparently can't be produced at normal body temperatures. They have to be lower than normal body temperatures. Why that is, I'm not entirely sure, but that's the case. Mammals that don't have external scrotal sacs like dolphins, they actually have a really complex system of blood vessels that carry cold blood from like their fins into their where their testes are to cool them down there. So it's kind of a workaround solution for them. The penis is the male organ of copulation, also for urination there. It delivers sperm into the female reproductive tract. There's three major regions that we look at: the shaft, what's called the glans penis or the large tip, and the prepuce. And then, as I mentioned before, there's also that root of the penis, which is inside there. So internally, there's three areas of spongy erectile tissue around that urethra. And erections occur when this erectile tissue fills with blood during sexual excitement. So other things to note is that the prepuce here, the foreskin, is often removed through a process called circumcision. It just happens. Some people have it done. All right, and then the chief role, as I mentioned before, the male is produce sperm, produce testosterone. So sperm production begins at puberty, continues throughout life. Millions of sperm made every day, about 1,500 per second, something like that. Formed in the seminiferous tubules through spermatogenesis. So the very primitive stem cells are called spermatogonia, and they just divide rapidly. And this is started with something called FSH, or follicle stimulating hormone, which is secreted in increased amounts, causes the spermatogonia to begin dividing rapidly. And that's happening inside the seminiferous tubules there. So this is kind of a cross-section looking at some of the seminiferous tubules. So you have these spermatogonia, the ones on the outside, the stem cells. They're going to divide, and then as they become further divided and more mature, they're going to end up in the middle of those tubes, and then those tubes will travel through the seminiferous tubules, eventually making their way back to the rete testes there and in the epididymis. On the right here, you can see kind of this different progression of maturation of those sperm cells. So they mitotically divide, they go through meiosis, they split from one end to two end into individual cells that are one end, and then divide further and divide further until they become kind of mature sperm down there. All right, so each division produces a type A daughter cell, contains a stem cell population, and a type B daughter cell, which becomes a spermatocyte and becomes 4 sperm cells there. So meiosis is a special type of nuclear division, produces 2 successive generations, and results in 4 daughter cells that are gametes. So gametes are spermatids with 23 chromosomes. So we talked about haploids. So these are haploid cells, right? And then the union of a sperm, which is haploid, with an egg, which is haploid, creates a diploid zygote of 46 chromosomes. And we saw that image before there: meiosis, fertilization, mitosis, back to adult bodies. Okay. So spermatogenesis, so spermatids are non-motile and not functional as sperm. So a streamlining process is needed to strip away the cytoplasm and modify it into a sperm, which has 3 particular regions: a head region, a midpiece, and a tail region. the headpiece, on top of that, there's an area called an acrosome, and that contains digestive enzymes that allow the sperm to potentially penetrate into the oocyte of the egg when it gets there. As we mentioned, 74 to 64 to 72 days on there. Here's an image of the sperm. So you can see the acrosome over the head, the mid region, which is this right here, and then the tail. So here's another view of the acrosome with the nucleus inside of it, and then the mid piece right there, and then the tail that goes along there. All right. So during puberty, these follicle-stimulating hormones begin prodding the seminiferous tubules to produce sperm. At the same time, luteinizing hormones begin activating the interstitial cells to produce more testosterone. This signals the onset of secondary sexual characteristics, bigger body, deeper voice, more muscles, and so on. So, just going to look through those. So testosterone stimulates reproductive organ development, underlies sex drive, and increases these secondary sexual characteristics. And again, testosterone is just a hormone, so any body, male or female, anatomically that starts out, if you give it testosterone, all of these things will start to happen: deepening of voice, increased hair growth, enlargement of skeletal muscles, and so on. Okay. So this shows you just kind of the pathway of looking at our pituitary gland and kind of things that happen with the pituitary gland that ultimately end up with more testosterone production and spermatogenesis happening. All right, and last little bit we want to look at here for males is homeostatic imbalance with erectile dysfunction. So this is the inability to achieve or maintain an erection. Causes can be psychological or physical, or chemically induced on certain medications. And I found a good video. It's Osmosis video. If you want to watch this one, you don't have to, but it gives a good overview of erectile dysfunction, its causes, and some of the treatments for it. All right, and that wraps us up. All right.